Onward.
Alrighty, I'm just have to take my time between slides here.
Yep.
Alrighty, so tonight's presentation is on PXE or network booting Raspberry Pis. And PXE stands for pre-execution environment. I'm not really up on my terminology. I've been using it for so many years, I don't even think about what it is anymore. I just go right to it. And so, I need to go back to the right machine to change slides. So, I am William L. Thompson Jr. I'm a big privacy nut. That's why you're not seeing me on camera here, but you got a little bit of me. There's my various contact information, my email address. You can reach me at WLT at Freenode, my IRC channel, or on GitHub as well. I'm pretty active there. Yeah, that's how my life is. My lips are always moving like that. So, um, I'm a developer and system administrator. I code mostly in Java and C, and I primarily run Gentoo. I've got a little bit of a background there with Gentoo. I'm infamous in some open source communities, including the Gentoo one. I've been around Linux and FOSS for around 20 years, and I've been a member of JaxLUG since 2003. I'm a wannabe maker. I'm seeking to do more with pies and BeagleBones, and I have to give a shout out to the BeagleBones because those are made here in the United States, where the pies and the Arduinos are made overseas. And I'm a pretty verbose person, so I'm going to try to keep it as short as I can tonight so we can get through this in a reasonable amount of time. These slide delays come. It takes a minute before it shows up on my screen, so I'm just going to kind of assume you guys can see the next slide. So an overview of tonight's presentation.
It's only like 5 or 7 seconds into
Okay,
the stream.
so like count to 10 every time I change slides or something. So we're doing PXE netbooting pies, and it's generally considered beta at this point. If you talk to the actual people making the software, they're still kicking out new versions of the binaries that we're booting off of the kernel and some of the other different binary blobs that are important for this working. It's pretty stable once you get everything working, although the process to get things working is anything but stable, and it's pretty frustrating. So that's why I think they leave the beta tag on there for now. This presentation tonight is going to be general concepts. It's not going to be a step-by-step or a how-to or a guide. There's a god-awful amount of links and blogs and documents out there on this exact thing. I put a bunch in the ones that I use in the references, so I'm just going to kind of go over some of the stuff that I had to like pillage from the various ones to do what I was trying to do. The basic concept here is that the Pi boots off the network, usually off a server. It's going to use a variety of software for this, and I'm not going to go into the configuration of the different software because those can be presentations on their own right. It's going to use DHCP to initially get its IP address and the address of the TFTP server. And TFTP is like it's called the Trivial File Transfer Protocol. It's a FTP server that doesn't have any login or anything like that. It's mostly used in voice over IP or in PXE. And the TFTP server basically just serves up the kernel and the necessary boot files, all the stuff that's basically considered beta. And then the NFS server in this situation is going to provide the root file system. This is just one approach. There are many ways of doing this, and I'm actually going to kind of show two approaches at the end here. I'm sure I've omitted a bunch of crucial details in this thing. I was kind of slapping stuff together, so if it seems I'm missing something, or you feel free to say, hey, you forgot that, or if you find something later on that wasn't in my presentation, I'm sorry, I didn't mean to omit that. So hopefully I've put all the gotchas in here, so that's kind of the most important thing. In hindsight, I probably should have documented everything I was doing first and then presented second, but we're doing things the other way around, so I'm presenting first, and then I'm going to document all the stuff later on. The main purpose for me to do the PXE or network booting of the Raspberry Pis is for help with mass installations. I was working between 20 to 30 different Pis at a time, and we were having to do installation of Raspbian to the SD cards. We were using an actual SD card copier that had about 7 slots outside the master, and it took about 30 minutes sometimes to copy all the things over the 7 different images, and then from there we still had to do some other stuff to it. So it was just horribly inefficient. And of course, while the SD card copier was doing its thing, we were just kind of twiddling our thumbs. So it was also not just a slow process, but those SD card copiers are pretty expensive devices. So this is a more affordable way of going about that whole thing in a much faster way, because essentially with this, you could do as many Raspbian installs as you have network ports or whatever the limitations of your network is as far as the capacity. This is a work in progress. I'm still dialing various things in for my use, and I keep running into new issues all the time. So from there, do some pauses here as the slides change so y'all can see the slides when I change them. The benefits for network booting a Pi is that you don't have an SD card or any other local drive. SD cards, they're pretty much unreliable. I mean, even the high-end ones after a period of time are going to wear out and burn out. They can also be stolen pretty easily. I mean, I assume if you're using Pis in production, you probably have the Pi somewhere that's semi-safe, but those SD cards are just so easily removable that somebody can grab one of those things and you'd never know the difference. So they're also pretty easy to lose. If you make a special SD card and you want to keep it somewhere, you can misplace it really easily, even if you label it. And they're kind of hard to track when you start getting stacks of these things. So it's also a security concern because anything you're doing with the SD card, your data is going to be on that SD card. Where if you're just using a network and you're writing back to the network, somebody could actually steal the whole Pi itself, and you've not really lost any data. So the Pis are cheap, but your data really isn't. So that's kind of the main concept behind this. You also have the reliability factor because when you're using server storage, you have RAID, you have storage area networks, you have all kinds of different solutions for server storage that you don't necessarily have with an SD card. So there's a lot of different reliability benefits you get to that. Not just alongside the reliability, you also get centralized storage, so you can manage all the different Pi instances or all your whatever you're doing with your different fleet of Pis all in one location, and it gives you one location for backing them up. And just on the concept of backing them up, if you have 10 or more Pis and you're running a backup script on each one of those things, the Pis don't have a lot of processing power, so doing a job like backing up is going to really tie those things down. So if you offload that work to a server, that really kind of alleviates the Pis to do their little workload. Some of the other benefits too in different scenarios is you can do shared binaries and shared systems. You can have like one set of binaries on the server and just kind of bind mount those and reshare those same things over and over again. So you can just kind of have one instance to maintain, and you can scale that thing up to as many Pis as you plug in. So the scalability is the other aspect of that, because once you start having, I'd say upwards of 3 or 4 or 5, 10, 20, 30 Pis, you definitely have to start looking for other solutions other than the SD card or even, external drives attached to each Pi. It just becomes unwieldy real quickly. So this is probably one of the only way to manage a large amount of Pis. And the other benefit, at least in my situation, was you actually get to use the SD card slot. So when you network boot, you can actually use it to actually, install Raspbian or install other images, or just use it as a regular SD card writer for various purposes. And in my instance, it actually was much faster to use the SD card for installation. Even beyond USB. Just tonight, I did an image using DD to USB, and it ran about 7 megabits, and that's kind of the low side of what I've been seeing through network copying, and I've seen upwards of like 10 to 12 megabits per second, on some of the different networks, which is pretty decent performance overall. So I think that's probably the one thing I left out of here was the performance aspect. But if you look at some of the different comparisons that people have done between network booting Pis and the SD card, there are a couple instances where the performance of the SD card actually is better than network booting. So that's why I kind of omitted performance as one of the benefits, because it's debatable. Give a few seconds here for the next slide. And so hopefully you guys can see this. Now, the system requirements you need basically to get this going is you need a DHCP server. I prefer ISC DHCP, the Internet Software Consortium DHCP. Most people don't. A lot of people like using DNS mask. I'm still kind of more the old school Unix philosophy, where I like individual programs versus programs like systemd that do everything. And DNS mask is kind of one of those things, because DNS mask will do DHCP, it'll do TFTP, it'll do DNS, and there's just, that's why some people like it, they just have the one thing for all. For TFTP, I prefer the TFTP HPA server, and I have no idea what HPA stands for. That's an actual server that's maintained by OpenBSD, and it's hosted on kernel.org. And it's probably the more reliable, current, more robust TFTP server. Although, again, a lot of people like to use DNS mask. There's also AFTP and some or ATFTP and some other ones out there as well. So for my setup, I use NFS server, but there are various guides and how-tos out there where people are using iSCSI SAN, so that's another option if you don't want to use NFS, but I've always been just a big fan of NFS, so I go with that. For the distribution that I'm actually booting the Pis on, I'm just going to demo Pi. I'm just using Raspbian for right now, because that was the criteria for the mass installation that we were doing for educational purposes. But we pretty much can use any ARM or any Linux distribution that supports ARM. And you basically are putting a copy of that Linux distribution in a directory, at least for the NFS purposes. That may be different for iSCSI. This is definitely confirmed to work with Pi 3B, 3B Plus, and 4Bs. I believe it will also work with 1B, 1B Plus, or 2B. Anything less than a 3B Plus is going to require an SD card with boot code bin on it only. So you have to have like a single partition on there and just this one little file. And that boot code bin is actually what tells it to look onto the network and has all the PXE booting code in it. For the older Pis, and again, I haven't confirmed this, but I believe you still need to do this on the 3Bs and some of the other ones. You have to actually boot them into a regular installation of Debian first, and then change one of the settings in the config text file to have it boot from USB, and that also enables booting from PXE, even though you're not booting from USB. But that is another option to do, but we're not covering that tonight. And there are some guides that, and I even did this when I got my first 4B, although I think it was completely unnecessary, and I know it was unnecessary on a 3B Plus that I opened up new out of the box. But there are various guides that show EEPROM updates for the older Pis. I would say try network booting first. If you run into issues, then start doing updating and stuff like that. But if yours works with network booting, then I wouldn't bother with that kind of stuff. The biggest gotcha that I'm going to mention again later on, because this bit me more than once, is try to always get the latest boot files from the GitHub repository. You want to download directly. Don't use a copy of them from a Raspbian installation, even if it's one that just came out. I know they just had a new release, I think on the 13th of March, and that should have fairly new boot files. But I bet you if you look on GitHub right now, the file they probably have put a newer kernel, newer boot code bin, and some other stuff like that. So you always want to use the latest files because those are the most crucial for the boot process. Now, the biggest gotcha for me on doing the stuff with the Raspbian installation or just network booting Pis in general is they don't boot with standard PXE. So if you already have a PXE environment set up, you're already network booting servers, this is not going to do any of that type of stuff. You can't use Grub, you can't use PXE Linux, you can't use any of the standard stuff like that, which is really kind of frustrating. And even if you have some of the more common options in global scope, the file name PXE Linux.o, it's going to cause problems for your booting. So at least in my environment, I had to kind of temporarily disable my previous PXE environment to kind of set up one specific for the Pis. So they're a really unfriendly environment. You're not going to get menus. You're not going to get boot options. You're not going to be able to select different kernels. It's a real crippled kind of environment, and hopefully maybe down the road some of those things will come. You probably could make your own if you did like the KXX stuff where you're booting a kernel and booting another kernel after that, which is what they do like with the noob software. But outside of that, you're fixed. I mean, you can change stuff in the command text file, but that's about it.
Yeah, I'm not sure as a insert in. I'm not sure about Pis specifically, but we used to do PXE booting computers back at the hackerspace when we were running that, and we were able to load the PXEboot image, and then inside of that image I could build a menu, and I built a menu, and you would have your selection of different Linux versions that you could boot.
You have with a normal PXE environment, you have all kinds of options like that. You have none of those with this.
Gotcha.
Because I don't really entirely understand it, because if you think you can buy network cards that have full PXE abilities, I don't understand what the limitations on the Pis are, why they can't give you a full PXE environment, but it really is just it's non-standard. So anything you're ever used to about from PXE environment, you pretty much have to forget all that stuff when it comes to the Pis.
Yeah, because the cards all had like either the motherboard cards or Intel cards or whatever. They had PXEboot built into their firmware.
Yeah, I mean, I would almost even not call this PXE booting, because you're really not doing anything a standard PXE way. The only reason why I would even utilize PXE is because if you look in like certain identifiers, like right here, this PXE client thing, they put PXE in there. They didn't have to do that, but that's one of their client identifiers. This may be a standard option right here, but I know this one isn't, the vendor encapsulated option. And this is the other version of it for DNS mask. Some of the older versions of this, you actually had to have 3 spaces after boot, because I guess it had a character requirement that it was looking for. But almost anything I've come across these days, and even some of the more the newer guides, they don't have those extra 3 spaces. So you shouldn't need that now unless you're working with a much older unit. And one of the worst problems that you're going to experience with these Raspberry Pis is they have a very short window for the network booting. You have roughly about 30 seconds, and it does not retry. So if for some reason it fails to acquire an IP address in that period of time, you have to power it down, power it back up, and then you can try to get your IP address again. If you're dealing with any sort of switches, like Cisco switches, you have to enable port fast for SMT protocol on those things because it takes a Cisco switch about 30 seconds to activate the port, which is about as long as this thing's waiting for an IP address. So on a typical Cisco switch, as soon as the port comes active, the PI is no longer waiting for its IP address again. That's a pain in the butt. So that's one of the other big gotchas to look out for, is to make sure that you the port activation on the switches happen quickly, because if it doesn't bring up the port in 30 seconds, forget about network booting a PI. Get a different switch or try a different configuration. So one of the other things too about this, going back into the options that I was just showing you, is that when you start having a bunch of PIs, you have to have each one of these options and each of the host configurations, which can get ridiculously unwieldy. If you have 20 or 30 PIs, you don't want to have 20 or 30 entries of the TFTP server name, the vendor class identifier, the encapsulation options, those type of things. So one of the articles I came across was utilizing the class aspect of IHC DHCP. I'm not sure if this is possible with DNS mask. DNS mask is kind of a more simplistic software. That's why it combines the functionality of 3 different suites into one. ISE DHCP is much more robust, so and that's part of the reason why I stick with it. But this is a particular setup here which allows it to match. I'm going to get these wrong, but I think this is like the prefix for the Pi 3Bs, and this one's for the 4Bs. But basically, any MAC address that starts with these, it's going to utilize these options, and if it doesn't, it's just going to ignore this whole section. And there's 2 sections here, because this section is actually here just for the net booting aspect, for to transfer over like the TFTP server name, the other the other specific options that the Pis require for them to boot. And then I'm also looking for this identifier. So not only do I have to match the MAC addresses, I have to match this identifier right here that comes across as well. And again, that's where they put their little PXE client in their thing too. So I guess you can call us PXE, but it really is very different. And then this one down here it may or may not be required. If you have your NFS server in global scope, then it's not as much required. But if you have more than one root paths, you're going to want to nest these in somewhere. You don't want this as part of your initial the initial DHCP information, because this comes later and this stuff isn't useful for the NFS server, and the NFS server information isn't useful for the TFTP and the initial booting aspect. The reason I also have this here is because I had a couple times where we get to the point of just about to mount the root file system, but then it would lose its IP address. So I have this here just to ensure that it gets this root path here to the server, but you can experiment with that. You may or may not need this section as far as that. But once you have these 2 sections in there, you can plug in as many PIs as you want, and it'll do its thing, and you can kind of go on from there. So it makes it much more friendly to deal with the large amount of PIs on the DHCP aspect with network booting and with this approach. Now, the TFTP directory layout is a bit different, again, because even though we're kind of in PXE booting, we're really not. The PIs look for their kernels and software in very specific locations. By default, it's going to look in the root of the TFTP directory, so you can't change that or provide paths or anything like that. One of the things that I don't like about that is if you already have other stuff in your TFTP root, like if you already have a PXE environment set up, you're going to dump a bunch of other files in there just specifically for PIs. And it can be for a single PI, maybe 5 or 10 files. But if you're doing it for all different versions, I think it's like maybe 20 files. So it just is kind of messy. There is an option to use a device-specific directory for each device, and you basically name a folder using the device serial number and TFTP root, and then you can put all your files in there. And you can actually just put in the files necessary for just the version that you're booting. So if you're booting like a 4B, you can just put in the boot files for the 4B or for the 3Bs or for the other ones, or you can put them all in there, and it'll choose each one. The downfall to that approach is there's, as far as I know so far, only one way to get your serial number, and that's to actually boot up the PI and cat proc CPU info and get the serial number there. At least the ones I've come across so far, the packaging does not have the serial number on it. There's no serial number externally. And even more ironic, a portion of the serial number is the unit's MAC address. So you can kind of get like, I think it's like a 8-character serial number, so you can get like maybe 6 or 4 characters from the MAC address, but then the other 4 you can't get. So that's kind of a really annoying aspect to actually have to do an installation of Raspbian just to kind of, or anything, just to get to the just to be able to get the serial number out of the device itself. So But it does make it a little bit nicer because you can clean up your TFT root directory. Although, again, if you have 20 or 30 of these things, it's probably just going to be easier to just dump the other files in there than to have a bunch of other specific directories for each device in there. But if you have different device configurations and stuff, then it would be an option because you can put different uh, command line text files in there and go from there. And once again, you want to make sure you get all of your boot files from the GitHub repo directly. If you look at that repo, they update them, I'd say 2 or 3 times a month. So in between them actually doing releases of Raspbian, they've updated those files several times. I've had a variety of issues where systems hang, crash, don't boot all the way, simply because I was using older boot firmware, older kernel, older boot code bin, stuff like that. So you want to make sure that you're using the latest stuff anytime you run into issues. It's just something to kind of rule out. Worst case, you can always go back to older versions, but it's best to start out with the latest stuff. The biggest thing about your TFTP directory is, which is going to control the boot process, is you need to edit the command line text file. In this situation, that's where you're going to change the root from a regular device like, dev, MMC block, something like that, over to your NFS. You need to add specific NFS options that are telling you, what the IP address of the NFS server, the path that you're mounting. A lot of distributions are using the serve directory now, which I like, and usually there's an NFS or a TFTP directory in the serve directory. I haven't adopted that necessarily on my server, but I'm doing it on my Pi, and I'm trying to get into a better habit there. And then you want to use like the version 3. You can also put in like other options, TCP, UDP, stuff like that, if you want to kind of control your, the different aspects of NFS. You also want to specify your root file system type as NFS. That's just another NFS quirk. That's not something standard you'd see in Linux. And then you also want to do your IP DHCP just to make sure it retains its IP address as it's booting up. It should sometimes without that, but if it loses it, that's why. So you put that in there and it shouldn't lose it. Personally, I like to go into no quiet and no splash, especially with your first setting this up. Once you get everything working, you can get rid of those and go back to just the quiet boots, quiet screens. But that way you can actually see what's going on. You can see, I think the no quiet gives you your D message output, and the no splash allows you to see all the stuff system D is starting or not starting. So those can be pretty important. NFS, and again, I'm just assuming most people have an understanding of NFS, and some of these things I've already set up. And NFS is pretty basic. I mean, once you install the software, all you're doing is editing the export file and adding in things to export. If you're just doing a single installation or a single directory per system, then all you have is a single export. It's pretty simple and basic. If you're doing shared systems, you're going to have multiple exports. Your base export is going to be this one, and then you're going to be bind mounting all kinds of stuff on top of that. Even though locally you can see the bind mounts, a lot of times when you are booting a system, they may not be able to see all these. For example, one of the issues I ran into is that the Pi was coming up, but it couldn't find init because bin was empty. So when I added this particular thing, bin populated, and boot populated, and home populated, and all the other stuff populated. What you won't see here are the directories that are specific to the actual system, which would be directories like var, etc for your configuration. Anything that's going to be kind of specific to the system, you won't want in that. And whether you're using a single export or the multiple bind exports, as you saw on the previous slide, the command line text, it doesn't change. So you still have a single mount point for the boot purposes. These are just kind of another little NFS quirk with how it works. And the other kind of things to look out for in here is that your main export has to have cross mount, because you're laying over stuff, you're just laying other mounts on top of it, your bind mounts. I threw no hide in there too, just, these two shouldn't be required, but I kept having issues, so I just kept them both in there. Then for all the other ones, I put in no hide there, so it would actually be visible once the NFS partition was mounted. So NFS can be kind of quirky sometimes.
What version of NFS are you using?
This is for NFS version 3.
There you go.
So I don't know if you call that, like, back up real quick on the last slide here. You could switch over to 4, but I think 4 has some other requirements. You may have to do like an inet ramfs, and that gets a little bit more complicated when you're doing the network booting stuff.
Right. 3 is pretty basic, but 4 has some interesting. 4 is very nice, but it's got a lot
You
of
could
stuff.
even go down to 2. I know on my previous diskless presentation I did back in 2011, I had some issues where I had to initially start out in 2 till I got the inet ramfs, and then I could switch over to 3. Or actually, it may have been booting in 3 and then switching over to 4, because I know 4 you have to have a daemon running for your user mapping. So there were just some other issues why I wasn't even going to try to attempt 4. I ran into so many problems with just getting these things to boot as it was on these things that 3 was good enough for me. So And this just kind of gives you an example of
Yeah, I just wanted to point that out additionally, just because I've always had problems with 4 and doing simple things.
well,
So,
4 comes with a daemon that handles the user ID mapping, and so you have to have that software running. And in a network boot it's an environment, it gets really weird because you kind of have to hand that over.
right.
I believe that's part of my. If it's not, I know it's part of the process of what I did when I did my diskless systems back in the day, because that's where I had to introduce an iNet RAM FS so I could get the proper ext4 NFS4 environment set up to be able to actually mount the root file system as NFS4 and then go from there. So, although it might even be the other way around, it may have just been booting at 2 and then going up to 3. So, what this is an example of my Pi 4, because I have my Pi 4 set up to where you can actually boot other Pis off my Pi 4, which I'll demonstrate later on. And so again, that previous example you saw, these are the reasons why you need all those different exports, because I'm mounting the local directories over here. So I don't want to actually have another installation of my Pi on my Pi, because I'm only booting a single one at a time off this thing. So it's just easier to kind of reuse all the binaries that I have on my Pi already. But that, let me go back to the previous slide. That was the reason why I had all these, is because all these are bi-mounted directories. And so this is just showing the example of what those bi-mounted directories are. But because this one still actually is using an SD card, this is not commented out of here. But that's another thing we'll get to here in a second. So if you're dealing with Raspbian, one of the things you need to do is, like I was saying, you need a copy of it on your server in a single directory in the NFS directory. Probably shouldn't have mentioned that here, but you see down here, I put it in the serve NFS Pi, so that's going to be the root directory where this gets unpacked to, basically. And the thing you have to look out for right here is the start point of the second partition, because you need that partition offset to be actually to mount this image and extract the files out of it. There are other ways you could do an actual installation and copy the files over that way, but that's kind of a pain. So this was a real kind of nifty little way that I came across to do this. And basically, when you get this number, you have to multiply the number by the sector size, which is 512. I've worked with 3 or 4 different versions of Raspbian. These numbers seem pretty consistent, but it can't ever hurt to always just do an fdisk and see what these numbers are. Almost every time it's come out to be the what is that, 532,480. And then when you calculate the offset, you multiply that by 512, and it comes out to the 272,629,760. And then that's what you're going to pass along down here when you go to mount it. So if you see I'm specifying the offset right there, that's the calculated offset. That number times 512 gives you that number. And then you specify your image, and then mount. I mount it to a temporary location mount. You can do a temp kind of anywhere you want, and then from there you're just copying this stuff. And the main thing to remember here is the P, because you want to preserve all permissions, all ownership, all that type of stuff. If you just do a copy recursively, everything's going to be owned by either root or whatever user you copy all that stuff over with, and you're going to have all kinds of problems when you boot that system, because any users that exist on that system aren't going to own their stuff anymore. So before your first boot, you definitely want to edit the etcfs tab. You need to comment out boot and the root mounts. Your file system's already mounted, so you can pretty much just nuke that file, although it does have a mount point in there for proc, so you probably want to keep at least that out in there. I understand that question. Host and username and dependencies for such for every device. For the host aspect of it, that's why I have a separate etc directory. Let me go back up real quick again here. If you notice here, I'm not bind mounting the etc directory. I'm not bind mounting var. Same thing here. Those are actually going to be specific directories so that you can have device specific options on there. You can set the host name for each device. You can set the username, stuff like that. So in this situation, just all your binaries should be shared. All your commands, things like when you update your system, all that same stuff would be updated for all the different systems. So if that makes some sense there.
So I guess the question as I read it is, when you PXEboot 10 machines, why do they not all get the same host name?
You have different etc directories.
You're configuring each etc directory before that Pi tries to boot.
Yeah, that's the one thing I kind of omitted. I was trying to figure out how I can squeeze it in here as far as that. Basically, anything that you're not seeing here is just a regular directory under Pi. So under Pi, there's going to be a var directory, there'll be an etc directory, and those aren't shared in the system. That's why if you look on the next slide, you don't see. I'm not bind mounting etc. I'm not bind mounting var. So anything that would be specific to that device gets its own folder on the server. And again, I kind of blew through that because that was all kind of covered in one of my previous presentations back in 2011 on my diskless systems. So I should probably have added more of that here, but this one was kind of getting big as it was. So all right, let me get back to where I was at here. So okay, so and again, so you're editing your etcfs tab, and you're commenting out your bind and root mounts because you're not mounting off the SD card anymore. And if you don't do that, you're going to have an issue when you first try to boot because it's going to boot up, and when it gets to the it's going to boot the kernel fine, but then when it goes to mount the root file system, it's going to try to mount them for an SD card that doesn't exist, and it's just going to hang and panic, and you're going to have issues there. So that's probably the biggest gotcha that you have to do before you boot. Everything else, for the most part, is optional. You probably want to optionally copy over SSH keys so you can log into it. If you want graphical or multi-user command line mode, you have to change that directly. Any services you want to enable or disable, you have to do that directly as well, via modifying the symlinks in etc system directory. If your system has ability to do an ARM specific chroot or an emulation of ARM, then you can fire up that environment that you have for your NFS and then run the actual commands like system control. But if you're just on like a 64-bit, AMD 64-bit server, you're not going to be able to run system control. And if you do, it's going to modify your server, not the environment for your Raspbian. And if you try to chroot into your Raspbian environment, it's probably not going to work because that's going to be an ARM environment, and you're going to be running it on a different architecture, which is not going to allow you to run any of the binaries on there. So, for example, if you want to enable SSH, you actually have to go into your etc systemd directory and then link it into there. And you can specify a name after that, but if you don't, it's just going to put the target in there, and then it should start it up by default from there. One of the things about a normal Raspbian installation is if you wanted to enable SSH, you could touch an SSH file in boot. That's not going to, you can't do that here because that boot file is going to be on the TFTP server, and it's not going to recognize it at all, and it can't remove it or do anything with it either. So that really isn't an option. So if you do want SSH, you need to make sure you enable that, or boot the system up, and then with a terminal on one of your netbooted systems, start SSH that way. And you may want to disable some other services. You don't need to do your EEPROM update. It's probably not recommended to do that because you don't know which Pi that may end up going on to or not. So you don't. The swap file service is good to disable, but it's probably going to fail to even create a swap file to begin with, at least using NFS. If you're using iSCSI, that may be a little bit different, but it doesn't like to do swap files over NFS, so it's not even going to try to do that either way. And there's a few other services that can fail on start that you may want to disable as far as that as well. So those are just the little things to do kind of before you get going. If you have issues, which you probably will, there's going to be a variety of things you need to do. The first thing is going to be to do TCP dump to see that you're getting DHCP and TFTP information. I don't recommend using combined commands because they're each going to spit out a fair amount of information, and they're really kind of a 1-2 step. So once you verify that you are getting the proper information via DHCP and you can ping the thing, then you can verify that it's getting the necessary files via TFTP. The TFTP debugging is not very friendly at all because the Pi is going to request files it doesn't even need. It's just going to try to request those, and if it's there, it'll grab them or not. It's really annoying process. I'm sure they have their reasoning why they do that, but you're not going to like the TCP dump or your log output from TFTP because it's just going to show a lot of activity. Most of the files not being found are not going to be an issue unless it fails to actually boot. If it fails to actually get a kernel and boot from there, then you're going to need to look into that. And the biggest telltale sign behind that is if you ever see that little Pi big square rainbow screen, then it's getting its kernel and stuff from TFTP, so you're for the most part good there. You could still have other issues later on, but that's usually a good sign from that. A lot of times when I ran into issues, because the Pis, like the 3Bs and the 4s, have 4 cores, the panic from each core can cause some of the important details to be missing off the screen. So if you go in there and limit the amount of CPUs you're using, you can actually get a little bit more of the kernel panic information on screen to actually give you useful information to actually fix the system. I needed to use that a couple times for NFS. That's how I realized that my my root bin directory was empty when it was looking for the inet binary, but I couldn't see that because when it spit out 4 cores worth of panics, that was off the screen, so there was not much I could do at that point, other than trying to maybe record it and playing back what you recorded and seeing it that way. But limiting the number of CPUs does limit the amount of stuff spit out on a panic, so that did help substantially, at least in my situation. If you do run into issues with the boot process hanging or crashing, once again, and using the latest boot files, I cannot tell you how many times that bit me, assuming that I had updated those and I didn't, and I sat there disabling services and trying to figure out why this thing was hanging and not booting all the way, and turned out several times that I just didn't update the boot files. So, that's why I've mentioned it 3 times now, because that's a very important thing to remember and keep track of. You also, if you do have services that do hang after you're running the latest boot files, then you could try disabling certain services. You may have to add the kernel option of systemd.confirm_spawn equals true. Essentially, that puts systemd into interactive mode, to where it's going to ask you if you want to start or skip any service as a service is starting. It can be pretty annoying at first, and the parallel aspect doesn't help with that much at all, but it is an option to kind of play around with to see if a service is problematic, and if that service is the one that is causing it to hang, then you can go in there and disable that service later on. As I showed you previously, the bind-mounted NFS shares do require additional exports. If you run into problems with that, what I was doing before is I was mounting my root share on another system, and then when I went into my bin directory, I noticed that it was empty. And so if there are directories that should have stuff in there, like lib, bin, user, home, any of the directories that you're buying, mounting, and exporting, if you mount that share on another system and you see those things are empty, you need to go back and do an export for that. So that's why you saw those different exports. Any directory that's empty that shouldn't be directory will need one of those exports. Beyond that, if you have other NFS issues, which you can, and NFS is not very friendly for diagnostic and debugging, you're going to have to look at your server logs for that. And hopefully your server is not running systemd, and if it is, good luck to you. And I'll tell you, throughout this process, I've always been kind of against systemd, but when I got into a situation of having to debug boot issues and debug hanging and debug crashing, systemd was not friendly at all. It was an absolute nightmare. I mean, just having logs in a binary format that you have to have a command to be able to access those logs, and I really grew to hate systemd. So I'm kind of looking forward to doing stuff with pies that are not systemd based.
Yeah, and that's an issue. Like, hey, I can't boot the Pi, but I need to get to the logs. But well, I have the file system, but they're binary. Hooray!
And binary from a different architecture, just the same way why you couldn't use system control to change and edit your services. You'd have to do that manually via symlinks. At least you could do that via symlinks, but the log aspect, if you don't have an ARM journal control or journal control that's built for the ARM architecture, you're not going to be able to touch those binary files unless you extract them over to another system, and it's an absolute nightmare. And then as you do have services that hang and other services start with the parallel aspect, there were several times where it dropped me out to a command line and it was still starting services. So my command line was like half up the screen, and then I had all kinds of other services starting after that. It would just if I wasn't an experienced user and I was sitting down there, I wouldn't know where my terminal was at, because the command prompt was mixed in between services starting. So it was one of the first times I could actually give solid reasoning why I did not like systemd, other than just saying that I don't like it as far as it not being the Unix philosophy where it kind of makes everything into one. So, and that kind of brings me into what's next. For me, what's next is to install Gentoo instead of Raspbian, or anything that'll use OpenRC or something other than systemd, because I don't want to keep having to do the systemd diagnostic nightmares. But for the situation I was dealing with the installation of the Pis, I needed to do Raspbian as far as the boot environment and what we were installing. So that's why I kind of had to make my way through it with systemd. I also want to turn a Pi into a general PXE netbooting device. I already have my Pi 4 set up to where I can boot another Pi off that, and I'll show you guys that here in a little bit. But it'd be nice to be able to take my Pi with me and boot any system off it that I need to, especially if you have to fix somebody's system. That way, instead of them having to bring the system to you, you can go to them kind of and do it there and make it out a little bit easier that way. And then ultimately, I really like to use my Pi for USB booting as well. So I could get other systems to, if the system doesn't have the ability to PXE or network boot off, like if you have a laptop that doesn't have a wired connection, you have Wi-Fi only, then you may only be able to do a USB booting off that to repair or do an installation on that. And when you're booting off a USB drive, one of the problems I found with that is that if you ever need to edit the files on that USB drive, you have to take that thing out, put it in another machine, mount it, change your files, put it back in another machine, and boot it again. Where if that was kind of a live, like a Raspberry Pi, I could just modify those files in the Raspberry Pi and just reboot the system that's trying to USB boot off it. So that makes that a much friendlier, more useful device. And in my opinion, it kind of makes it like the ultimate rescue device, because then I can either rescue a system via PXE or via USB. And pretty much anything these days is going to be able to do one of those two forms of booting. And kind of the USB aspect would also make it like a USB mass storage device, kind of like when you plug in your Android or other phones into your system, where you can transfer files back and forth that way. So that would be nice as well. So those are kind of the things that I've got planned down the road after all this.
Yeah, we going back to the PXE booting that we used to do. It is extraordinarily useful as a troubleshooting thing. You're not wrong. So like just having a PXEboot server just sitting around on your network that has a couple of images hanging out, and you're like, hey, broke this laptop or something's wrong with this thing, and you try to boot it off of the network, and you can end up making troubleshooting a lot easier.
Well, and it also, for example, in the Pi situation, it also makes a good backup PXE server, because, like, for example, my main server here is my PXE server as well. And if I'm ever doing work on that server, if it's ever down, I can't rescue my server with itself.
Right.
So having another device that I could PXE boot off of, it wouldn't be very robust, but at least I could kind of rescue my server if I had to.
Well, one of the things that I've done before that works out really, really well is to use a make a Pi that's a PXEboot server and a DHCP server, but the primary, your main server, is set up as what is it called? It's set up as a primary DHCP.
Oh, primary DHCP, yeah.
Yeah, and
So
so it
secondary.
overrides everything. And then the other
Right.
one, you don't set that up, the little Pi. And that way, if your primary server is ever down and then something needs a DHCP address and then also PXE booting, you can go to the Pi. Whereas primarily, it'll go to the main server.
Yeah, that's one of the things I forgot off my introduction. I'm a huge fan of diskless booting or network booting stuff. Anytime you can use PXE, I'm always about that. So I used to have a
That's
kind of
good times.
I would say a cloud, but I used to have a virtualization environment with Zen server, stuff like that, that was all based on that. And I could kind of scale up and down based on that. That was a presentation I did back in 2011. That's available on the LUG's website if anybody's curious about that. So, anybody else have any questions about this before I proceed on and do some demoing of this stuff here, which is probably what everybody wants to see before I take too much time? How are we doing time wise?
You're doing
Oh,
great.
it's not too bad. Yeah, Slacker is one of the good ones too. It's probably using OpenWRC or one of the other ones. So. But yeah, Rob, I don't know if I'll be putting the Slacker on the Pi. I think Gentoo is going to be my go-to for that. So it's just kind of where I'm more comfortable with. And also, I make a ton of Gentoo packages. So if I need to package anything, that's going to be my familiar format for that kind of thing, to package stuff on there. So I'll get to the last thing here, and these are all the good links. So these are the various sites that I referenced throughout doing this project. I think there may be a couple more that I may have omitted out of here. Obviously, it started with the default documentation from Raspbian, or from Raspberry itself. You got to remember, Raspbian and Raspberry are two different things, even though they kind of seem very related to each other. And then there's also stuff on installing Linux images. So I didn't really show my scripts here that I use, but I have scripts that I wrote to actually do installations of Raspbian or like the boot bin on a net-booted system, because that was the project that I was working on to kind of do all this type of stuff. Obviously, the most important link that I have in here is the link to the firmware, because you definitely need to update that. It's like the fourth, fifth time I'm saying that now. I'm only emphasizing that because I had that problem. So. And then other stuff, where you can get the TFTP software from kernel.org. This is for DNS mask. And then this gives you various kernel command line options as far as that. So now we'll see about having a little bit of fun here, and hopefully we don't have any sort of lockups or not here. So these are the different Pis that I'm working with. So I guess we can go ahead and get rid of the... I guess I'll stay in the picture there. But so these are the different Pis. Actually, am I showing these yet? No.
I can see the Pis.
Okay, good. They're still there. I forgot I keep having these two different... I'm running two different screens here, so I keep forgetting what's on what screen and what's on the other screen. So I guess I can leave that up. That was fine the way it was. What did I just do with that? Or fine a second ago. Whatever. So bring me back. Here, I'll bring. This is me playing with OBS here, so give me a second and I'll. Move a different window over. These stupid things, these windows. All right, so now I'll bring the pies back. Okay, so the black one is my Pi 4B, which it's having some problems right now net booting, so I'm not going to demo net booting that one. Then I also have Pi 3B plus right here in the middle, which is the main one I'll be net booting off of. At first, I'm going to net boot that off my server, and then I'll net boot that off the Pi 4B. And then this is a regular Pi 3B over here, which is just giving me all kinds of headache right now, and it's not really working for me. These are little touchscreen, little mini displays you can use with the Pis. They're kind of quirky. This one's not coming on at all for the 3B.
We can't see your mouse.
Yeah, I know. I'm trying to. I have to. I guess I can kind of. I'll give me a reflection, but no, I have to see. So I'll just try to name it better. The one on the one in black is the 4B. The one in the middle is the 3B plus, and the one on the very far end, which I guess at the top of the screen, that's the 3B, which we're just going to ignore for right now. And the one in the middle is the one I'll be working with for the most part. But at one point, I'm going to take its purple cord out and plug in a yellow cord, connecting it to the 4B, and doing that. So let me switch these over here and see how this works out now. So now I'm going to bring back this guy over here. Oh, no, I wanted that back on. Excuse me. I need to off my image. And I'm borrowing a HDMI capture card from Dan, which Dan decided to buy one that's Windows only. So I actually have to fire up a Windows machine to finish off my Linux presentation. Oh no, I messed with the driver software. I was enabling various options, and it's pretty confirmed at this point. So let's see how well this.
Write a driver for it.
Yeah. Oh no. Well,
NDIS wrapper, the Windows driver or something.
Well, keep in mind the N in NDIS stands for networking, and that's actually an architecture that went away with Windows XP. So anything after XP doesn't use that anymore. So that's not even something you can consider. Okay. And the reason that the guy who was writing the driver had to stop writing the driver is because Elgato threatened him basically with legal action because he was violating the license of the product to begin with. Basically,
Elgato, by the way, is Corsair.
Yeah. Well, and it's weird because I think, like I said, they also kind of addressed like the driver works with the HD60, but it doesn't work with the HD60S. And I think for the HD60S Plus, they decided to go ahead and use the UVC framework that's in Linux. I can't remember what UVC stands for, but it's like the Universal Video Control, something like that in Linux. Mm-hmm. And so with that, you don't need a driver. And like 90% of webcams these days are all UVC compliant. So that's kind of what they're moving over to as far as that. So. Yeah, there's pretty much no hope for that to ever have Linux support.
Yeah, well, that's the only one they had at the time. So. And
it's not a bad one, but anyway, so that's what we have going on here in Windows, and hopefully it's going to come alive here for me as we do this thing here.
Let's see.
Yeah, it should come alive right now because the screen came alive here. It's hooked up to this little screen here. If you can see my hand here. But let's see what happens here when I turn it off the signal. If we get the nice little, okay, so we get no signal now. So I'm going to power on the 3B or 3B plus, and it's got a sense hat on there, so you can't really see the little rainbow color, so it's kind of bright, but it's got like a little rainbow color that starts up with, and hopefully we'll get the signal to show up here on this other one. Okay, it's getting something. It usually kind of jumps in as part of the boot process. Not always will I get to see like the big rainbow color square. Should show up on the little screen over here, but it might not show up on the other one. Yeah, it skipped that whole thing. I have to reboot it to try to capture as opposed to.
I'm not seeing anything on the.
Yeah, it's really quirky.
Our
like
desktop.
Sometimes it does. Yeah, sometimes it does. Sometimes it. No, it's not our. It's the Elgato software on Windows.
Oh.
The video output when you're booting Pis is really quirky.
Actually, I was using OBS on Windows to do that, but
I don't even know if that would work because they would still have to get the stream from Elgato.
No, it was just streaming it straight from the device.
Oh, well, I didn't try it. Yeah, I probably
Yeah.
could have tried that. I'm using Elgato software, so maybe there's some sort of quirk, something like that in their software as far as that. Give me a second. Let me try to reboot this thing
When in
again.
doubt, boot it out.
Yeah, let me see if I can
Is
reboot
Windows
this
acting
thing real
funny?
quick.
Reboot it.
Yeah, no, it's not a window, and it's not always even a software issue too, because I tested this out prior to this thing coming on here tonight. Come on. I guess I can use my little mouse here. I got this little miniature USB keyboard thing that I'm using here.
Hmm.
Even though this is a touch display device, you still can't enter characters in with that, so I'm just going
Oh,
to
that's
try to
cute.
reboot it directly.
I like that.
Yeah, it's nifty as far as a portable thing to take around with you. See if it'll reboot and bring it up this way. This was being very quirky with me before, so hopefully it'll come alive one of these times with us here. I did that one with the power, so maybe it's better if I don't do the power. But for all intents and purposes, if you see here, there's no SD card in this Pi. So the fact that it powers up and gives me output on this little screen right here, it's just showing you the network booting in action. So if we get some output here, you'll actually see more of the kernel output for the network booting and more useful stuff. But in the butt tonight.
So you pipe in the output of that Pi into the HC60 and then the HC60 to the little screen there?
Yeah, the HE60 is going to the Windows machine, and then it was doing its thing before. Let me hang on. Get out of OBS here and go over to this here. It was see here real quick. This thing here is it should right now because it's got output coming to it.
Right. Could be just
I mean,
that it needs to be restarted.
this little screen is going
The
through
software.
the Elgato. Yeah. So why did you just turn off on me? Turns off right when I want it to. Oh, what are you rebooting? Looks like it. Because the Pi just decided to crash for me for some reason. You do. Really annoying when you enter the full screen with the stupid hide the sidebar. And there we go. Okay, so there's our little rainbow screen. That's basically confirming that it got its kernel and stuff from NFS. I mean, from TFTP. And then very briefly, you probably have to play back the recording, but right there's the IP information for network booting. Now it's coming all up here.
They make Pis fancy nowadays. 4 processors.
There we go. And it's funny because I have no signal on this one for some reason now. I'm going to be flying blind here. Well, see, that's weird. My touch is still working on this thing, but I have no display.
That's interesting.
I'm telling you, that's why I was a little concerned about the how this would work out there, because these things are so freaking quirky. The display aspect, it boots reliably, no problem. Even this 3B over here, it'll boot up fine, but I can't get the display to come out at all for some reason. So, come on, give me a terminal. I'm gonna launch a terminal so you can see the do like a quick mount thing on it, but I don't know what's going on here. Come on, there we go. I know, look, I got crazy mouse thing, but I'm using a little touch mouse thing on this little Bluetooth thing, so.
Yeah. Can you make the text bigger whenever you get a chance?
That's what I'm trying to get to.
Okay.
Oh, why it's lagging like this right now for some reason. Something's not happy. Oh, now it comes up. Now I'm trying to get off of it. Go back. No. Go down, go down, go down, go down.
Shift Control Plus.
Yeah, it's easier on this. I mean, this is not really like, this is a miniature keyboard. I tried doing that. Shift Control Plus. Go. Trying to do that on this little keyboard thing is not real friendly. All right, so now we'll just do a.
There we go.
Yeah, but that's an uppercase, so that's not going to work because I accidentally hit my big old fingers here. Accidentally hit the uppercase button. Okay, that's exactly what we didn't want. Have all this stuff up there. I got to scroll.
Just maximize the window.
That's probably a better way to go about it. I have more luck getting to that thing than I would trying to scroll over to it. Go up a little more. Oh, I missed it. Damn it. No, still too.
Maybe you're hitting it and it's just taking its sweet time.
There we go. And of course, it's still. I can't believe. Oh, it's because I have all the. No, this one shouldn't have all that stuff on there like that. It should be much more basic, but. There we go. See, so you can see now here, we got my root partition mounted here. NFS file system, so you can see there's no SD card attached. I wanted to click on this with my actual mouse, but I can't because this is my mouse, not the thing's mouse, so.
Do ls block. LSBLK.
Yeah, let me go backspace. No output because there's no blocks.
There you go.
And I think do I have them? I think I do. Let me see if I can minimize this thing again here. So, for example, you can see I have these little scripts sitting here on my desktop. I'm not going to do an actual Raspbian installation, even though one of those scripts is for that. But I'll do a quick the little boot code bin one that I wrote because it takes a few seconds. Other than navigating to the directory, it's got capital D. And this little keyboard isn't as friendly as it may seem like it is. Last resort kind of thing if you're out and about. You can see them sitting up here in the corner. These guys right here. So I'll pop in an SD card. You can tell now, see, if I'm sticking an SD card in there, obviously wasn't one in there to begin with. And see, it's telling me now that I've put an SD card in there. Yay. You're canceling that. Come on, just get out of here. That touch, the display was lit up. I could have used that because it's much easier to use the touch on that than it is for mouse purposes in this stupid thing. Okay, back in my terminal. So now here I'll just do.
But touch does work.
It actually still is functioning because it's got a separate cable that goes to it. So I mean, I just can't see what I'm touching on. And it's just neither is ideal. They're both just as bad. And of course, I should have used shorter names for this stuff. What do they call that?
Underscore bin.sh.
Yeah. This guy type, like, this thing is not friendly to type on at all. Let's go over here and just do my little SH and we'll be good to go. And I'll show you the script here in just a second. So really where I should be doing my bash foo, because there's a way you can use the previous argument for this one. So that's a little script that I ran. Basically just tries to unmount the SD partitions. It's going to create a single partition on there with MS-DOS label. It's going to format the partition. Then it's going to copy over the single file, and then it's going to unmount it, and then that's that. And then basically what that would do is I would take that SD card out of the 3B plus, and then I would stick it in the 3B, because the 3B and older ones require that little boot code bin to be on there. Or I could always run the other script that I have on there, which is actually doing an actual installation of Raspbian. That takes between 5 to 15 minutes, but I won't bother with that tonight, because that's just, you can get the idea for the most part with the boot code bin. But it would just basically write that Buster image right there to the SD card, just like I wrote the other one there. And so my final trick here is I'm going to power down this one, and I'm going to boot the 3B plus off the 4B. So we're going to be really crude, even though you shouldn't do this, but because this is network booted, it doesn't matter because that's on the server. So now I need to get my little crossover cable, and we're going to plug into the back of the 4B. And plug in to the 3B. And we're just going to take this boot code bin out of here, because that may cause some issues for there. So again, no SD card in there. And my 4B is already on.
I don't know if a lot of people remember, but back in the day when we had 100 megabit and 10 megabit Ethernet, you couldn't do that without a special cable. But now that
that's actually what that is. That's an actual crossover cable.
Oh, you actually have a crossover cable. Okay.
Yes, well, because these do not have auto MDX on there. So, and these are considered the
4 should have gigabit.
It does, but I don't think it has auto MDX on there as far as the sensing on it. And for the net booting, I didn't want to take any chances, especially when you're doing from like a Pi to a Pi.
Right.
Like I go through a switch, it's probably not as much of an issue, but because it's a Pi directly to a Pi, you need a crossover cable. Yeah. I tried it before. The regular cables, it won't work.
Huh. Well, it's supposed to work. It will work with most devices. And
if it was a 4 to a 4, it might.
If it's a 4 to a 4, some of the older ones, like what you're using, are 100 megabit. Which doesn't have auto FDIX.
Yes, the 3B definitely is. I can't remember on the 3B plus. I feel like the 3B plus got a gigabit, but it may still just have 100 megabit as well on there. So
something to note with all of the Pis is that they all still use the USB 2 bus. So even though you have gigabit on some of the newer ones, it still theoretically maxes out at 480 megabit.
I got a screen sitting here. You'll be able to see some of it, and this is my 4B right here. Got a bunch of bright lights on, so it's washing out the screen. But so I basically have a little script that I wrote on the 4B, and what it does, it just starts NFS, it starts DHCP, and it starts a TFTP server so that I can actually mount another system from it. So nothing special to it, but if you want to just see this little script real quick, I'll run this thing. I don't know how much of this you can see. Turn this. There's a camera and get less of the light wash. I should have already been in my desktop directory. And I actually have a regular keyboard connected to this one because I only have one of those Bluetooth things, and if I use it for more than one that's on at the same time, it's not going to work. So, I should increase the size of the thing again as well, since I have a. That makes it somewhat legible.
Why don't you make the screen bigger on your OBS?
Oh, that would help too. Well, I'm only doing this temporarily because I'm going back to. You're still going to want to see the 3B booting. So.
Gotcha. Picture in
All,
picture
all I'm
mode.
doing. Yeah, all I'm doing with this one is just running this little script here to start PXE. What the heck? This is for sudo. I think I should have. I think I wrote this thing to rerun sudo for it. Yes, I know. I typed in too many characters. I forgot to put sudo in the file, so what I needed to do was just do sudo the thing. And I'll put that script out here in a second when I'm done here. I guess I probably should do it now since I've already pointed at this thing here. All right, here you go, Dan. You wanted this bigger? Just turn it off in a second afterwards. And the reason that it says the bottom one failed there is because I didn't configure the DHCP 6 server. I only did DHCP for version 4. And that's just a very basic script. I mean, all I'm doing is starting the various stuff and configuring etho. I did have to disable the DHCP CD for that. Let me just cat that file. And don't get this confused with DHCP because this is a client. This is a client daemon. DHCP client daemon. And if you see down here at the very bottom where it says deny interfaces etho. So because of that, this thing will not get an IP address off its Ethernet port, but I had to do that to be able to statically assign an IP address to it for the other system to boot off of for that. And so now back to our little things here. So 3B is connected to the 4B right there. And we're going to come back over here and reboot the 4B again. So I'm going to shrink this. Yes, I'm still there. I guess I was covering myself up. And let's see how this works. I'll see if we get output on the displays again. I know it'll boot off of it. I just don't know if our setup here is going to give us the display output. We'll see. Oh, yay. So it's working for us.
All right. Oh, 2 processors on this one.
Because I think I still have the thing limited to 2 processors. So
okay.
that's the max CPU option I was showing you about earlier. So you see there's only 2 of the Pis up there because I still have that option up there as opposed to the other one. So
and for anybody that may not know, the 2 little Pis at the top, or sometimes penguins or whatever, when you see doing a boot sequence, is the number of CPUs that your system has.
And so I'll go back up here again. I don't have a Bluetooth enabled on this one. Where's my? Yeah, it should be Bluetooth. Oh no, I'll have it paired up with this one because this is net booted off the other Pi, so I got to kind of. I can't really. But you know what I can do is I'll just do this. It'll be easier. I'll bring up a regular terminal here. Come on, give me a terminal. Area this screen. All right, we'll just go on top of it. I guess we'll be nice and do Pi at 1.2.11, I think it should be. No, why don't I have a route to you? Their IP address that you weren't supposed to get? I know you have an IP address. Oh, what am I trying to do? I can't because it's connected to the Pi. I'd have to go into the Pi first, so let me... I have to go into the one before I can go to the other one. Oh, get out of here, email. Go away. Email thing popped up on my other screen, so that's where that just came from. Let me try this again. So I need to go into the. Okay, so that's me into the 4B, and then if I want to go into the other one, I can't remember what IP address I gave it. I think it's 2. I guess not. Should be still 11. So from here we can just say, or already pi. So we'll do 10.1.10.
I haven't seen that that little alarm thing for your system bell before.
Oh, that's part of terminology. It actually makes a sound and stuff like that. But yeah, that's part of the graphics of terminology.
It's cute. It's
Terminology is one of the best terminal emulators all around. That's part of the reason why I still run Enlightenment, that kind of stuff. But so once again, mount, and you can see here we got our mount point right here, and that's off the 4B because the 4B is actually running that IP address right now. Let me get another terminal. I'll show you that as well. Okay, past it. There's that there. And so I'll go into the 4B. This one actually has a mount to it. We're actually, just, you can see all my bind mounts and the actual regular stuff up top here. We have our regular root mount. And then here is where the
oh yeah, the other utility I was going to say is find mount. It's kind of an interesting one.
What's that?
Find MNT, find mount.
Oh, yeah, I'm not familiar with that one. So this is the 4. Let me. Say 4, and this is the 3B plus. That's booted off the 4. And here you can see the serial numbers I was talking about a second ago before.
Yeah.
And for example, if I go into my my server real fast here, just make a mess of windows here. Yeah, I know, root bad. And so if you come up here and look, I have directories that are named after these things. That's bigger. I don't know if y'all can see all that. Is that legible on that end?
Yeah. Well, I mean, I can see it, but they might not be able to see it on the YouTube.
Plus on these things? No. Roll plus. No. Okay. So I had to go into. Friendly as some of the other ones are. Probably the one downfall behind terminology, I guess. See these directories right here? Those are basically for me to not pollute my my root file system as much. And let me go over here and adjust the. 2014, something like that, doesn't matter. So you can see right here, this BA EB6121, and right there, same thing. So that's just how I map those on the TFTP server to actually get those to come up that way. So that's the other reason why you have to boot these things to get that stupid thing. Or like you can see on my 4B, I just have everything in the TFTP root. Do an LS on that. I'm kind of addicted to my LSL. So there you go. So that's the option. So that's what I was saying before. Like instead of having all those files in my TFTP root, As you can see, I have a lot less files. That's why I opted to create those directories as opposed to sticking all that stuff in there. Now, granted, since I'm only doing 3s and 4s, I could get rid of like the 2 stuff, the 0 stuff, some of this other stuff in here. But you'd be surprised which ones I'll actually use and not use. And it's just a lot easier if you're creating a mixed environment, just to leave it stock and then not have to upgrade each one of them as far as stuff like that. And then you can see the command line text that's in there as well. That's pretty much it, unless you guys want to see something else. And the room is silent. Dan, Mike, you still there? Mute? No mute? Hey. We lose everybody? Guess we lost Dan. Well, that's it. That's all the little good stuff here. I was going to do some more booting with the other little pies and stuff like that, but that's about it. So, if y'all have any questions or other issues with net booting pies, you know how to reach me. We're providing a link to the presentation for tonight as well. Guess I'll sit here until Dan takes a stream down or something like that. I don't know what happened to Dan. Still has power because this is still going on. It's all going through his location, so maybe his cat attacked him or something. Dan, where'd you go? Well, I guess I can show some of the other stuff while we're still at it. So like on here, this is all that bind mounted exports that I was talking about before, and this one doesn't have any of that. You can see these are commented out. Make this a little bigger. See, there's the only thing that's mounted here is a proc partition because I'm not doing any of this type of stuff because it's using an NFS root. You know, I think probably that would have been easier to do it that way. And you see here, you can see all the other bind mounts. Even though the command line only has a single one, you can see all those other ones showing up. So like if I go back here and I do cat serve TFTP CMD, I'm only passing along this. So I'm only passing along that, but it mounts all this other stuff too. That's why you have to export that stuff. If I hadn't exported that stuff, this would all be blank, and that was one of the problems that I ran into, which is why this thing's booting off of 2, and you actually see it right there to the Mac CPUs.
Sorry, I stepped away for just a second.
We kind of noticed because like I kind of ended the presentation and you were gone, so I kind of had to like keep on going. But it's all right if I showed a few more other things. So
I had to use the restroom real quick.
No problem. Just for your purpose too. I don't know if you've ever seen this as well because you're familiar with NFS, but so I'm only mounting this NFS share right here. But you can see when I did disk free, I have all these other ones as well. But I didn't tell it to mount these things. But if I hadn't exported those things,
right.
See how I have all these exports here? Those directories would all be empty. So bin would be empty, lib would be empty, user would be empty, all these would be empty. And that would basically mean your system wouldn't boot because the first thing it looks for is bin init. And if it can't find init, it doesn't go anywhere. So that's why all that craziness is and it's funny to me because using an NFS, like to have these mounts here, you'd have to mount those specifically, but it's not. It's not part of the command line. I mean, if I did
That's interesting. Is it like maybe auto mount system?
It's something to do with NFS because as soon as NFS hits those directories, they come alive basically. So they must auto mount themselves. Because you can see the NFS root right here only has that one. So that's all it's told to mount. Yeah, it's not told to mount anything beyond that.
It could be something with auto mounter daemon or the auto mounter programming or auto home or something. Because there's all kinds of weird stuff with that too. Huh. You designate the root server. That's interesting.
Yeah, that was that. Let me go back to that section again real quick. This section right here. This anymore, but
Hey, we got a like.
you're not slipped off of it. Yeah. So for example, this section right here, this IP config section, that's the reason why in the DHCP I have the second section. A little too happy with my tab completion. You haven't typed enough unique characters yet. Damn it, just show me the file. I'm thinking about it. Okay, so this is why, see I have these two different sections here. This second section right here is necessary for this right here. A lot of times without this, it would be empty right here. Even though it should pick that up from the command line text. It should pick it up from, on the wrong thing again. Yeah, it should pick it up from this, but it doesn't always. So that's why I had that second section in there on my DHCP configuration, this thing. So if you just have this section in there and you don't have this section and it fails at the NFS portion, if this is empty, that's why. So I just err on the side of caution and put this in there and it can't hurt and then it takes care of that and does its thing.
Cool. Well, very good.
And this right here is the line that I could not see without limiting the processors when it had a kernel panic. And I can't replicate that for you if you guys really wanted to see that, but that's the deal behind that. But it was also cool because I wasn't aware of the CPU option to limit cores. So that's also, it could be useful if you have a bad core, something like that.
Yeah, that's
so.
pretty cool. It doesn't let you specify which cores, but it does limit. It's probably like lowest to high. We have one question in here from Mo. Can you
Don't think
ISO?
you can do that. I know what you're after on that, and it'd be the same thing like if you left it as the image and you didn't unpack the image.
I think you can. From like back when we were doing it, we had Windows TFTP booting as well. But I think you have to basically wrap it in something. So you would build your PXEboot system, and then you build your like you tell it to basically chain load and then load the, I think it's HFSS file system off of the ISO. But generally you would unpack the ISO and then put it into the TFTP or NFS section, and then you would boot it like that. So for something
that might also
unpack,
be an option if you're using iSCSI as well, because iSCSI is a block storage versus a file storage. So that may work with that as well.
Yeah. Yeah, so there's ways around like if you want to do like Windows and you know, or a specific distro and they only distribute the ISO, you can actually mount that using a loopback device and then unpack it and mount like that. Or there is some kind of a way to chain load it. I'm not 100% sure on that. It's been a long time.
And actually, that's kind of a good question he asked with Pot's follow-up about Windows. Is I know they have Windows images for the Raspberry Pis. I don't think you could netboot one of those Windows images either. So
Really?
that would probably require something very specific and unique. So because all of this is exploiting features of the Linux kernel. So
right, and it might also be that it's PXE booting, or it's not full on PXE booting, because I know we did have a Windows environment that we had some people that would troubleshoot computers. So like they would bring a computer in that somebody's like, it's on fire, I don't understand what's up, and then you know they'd boot their Windows rescue environment, which would actually be a Windows image and had like a bunch of utilities on it, and do that. So it is possible to do Windows, or at least older Windows. I don't know about the newer ones, but you might have to do some like crazy tricks and stuff. I remember it was kind of painful.
That's also assuming that they support the ARM architecture, because they're probably either 386 or x86 or
PXE specifically, not for Pis. The Pis, I think there's a Windows version for the Pis now, or ARM version. But yeah, I don't know if that
I
works
I
for the
barely
PXE
like
boot.
even calling this environment like a PXE environment because it's just so different than a normal PXE environment for most stuff.
Netboot.
So
It's more Netboot
it's
than
just kind of,
anything.
I think, exploiting aspects that you'd use for PXE to kind of get the kernel onto the system. And once the kernel's on the system, it really has nothing to do with any of that stuff anymore. It's just a net booted, or it's just a diskless Linux system at that point.
Right.
So which you could possibly do without even having to do PXE if you exploit Linux kernel enough. So because I think there was people that had the like there was a Linux BIOS thing a while back that I came across too. So
All right.
yeah, so like that Windows 10 for ARM and Pi that Potts just mentioned, I don't think you could net boot that. You might be able to, but that'd be something Windows specific at that point. It'd be something totally different. All that would be the same would probably be the DHCP stuff, and then I don't even know what you would do for TFTP because the TFTP on this serves up the kernel. So
Right. Well, there's probably you'd have to load some kind of pre-boot environment and then load the main kernel in.
yeah, I'll leave that to Mr. Potts. He's our resident Windows guy with his career and everything. So
Right.
he
All
can
right.
do a presentation on network booting Windows on the Raspberry Pis.
Oh,
So
that'd be interesting.
yeah.
Do you guys have any other questions before we wrap this up?
Well, they did when I asked several times. I just kept going because you had gone away. So
I
I
was
was just waiting for you
I
to
was only
return.
gone for like 30 seconds.
Yeah, but I think you left right as I was ending the presentation.
Oh man.
Like, it was the perfect. I'm like, "Where's Dan?
I
Dan
knew
left
it. I knew it.
until
I'm
you."
gonna take off my headset for a minute, and like something's
Yeah,
gonna happen.
if you scroll up in the comments on it, you'll see it
Oh, I
there.
see
So
it. It's funny. I see all this
yeah,
applause, and oh, we lost Dan. I'm like, dang it.
so you can pop back in there if you want to close it out on your end or not, or if you just want to leave me on here or not, whatever you want to do there.
Right. So,
You want to make a final appearance?
no,
No.
it'll be fine. So thank you very much for presenting. It was really good. I always enjoy this type of thing. So,
It took a lot to come together. Again, just a recap for everybody. So I'm using my desktop to view the presentation on YouTube. I'm also running Discord on my desktop that I have my microphone connected to, so I can do the audio portion of it. And then I'm also using Synergy on my desktop to be able to control my laptop. And then on my laptop, I got the two different cameras going as far as that type of stuff. And then I have a Windows machine that's running this free RDP thing here, so I can use Dan's Elgato video capture card with the different Pis. And then all this streams over to Dan, and then Dan has two different systems going on at his location too. So
yeah. On my side, I have a Linux server that's hosting a RTMP instance that he's streaming his video to, and then I have on my Windows desktop, I have OBS running, and it's pulling in that stream from the Gen 2 server, and then I have Discord that we're chatting on, and then everything gets compiled into a single stream and then sent off to YouTube.
yep. So 3 Linux machines, 2 Windows machines, and a couple Raspberry Pis, and we did the presentation. So
And we
now
made
we'll have
it
to do a
work.
presentation on the presentation.
Right. I thought about it. Like that might be a pretty interesting thing people might like about seeing like how we can make it work with Docker and Linux and shifting material here back and forth and
Yeah.
doing stuff. And
Yeah, and
YouTube,
then a whole
yeah.
slew of
Oh,
software.
YouTube,
Yeah,
YouTube.
yeah,
Oh, man.
YouTube, Discord, OBS, Elgato. We're using all kinds of different stuff.
Yeah, and we got it to work. So,
Yeah. So,
thank you very much
well,
for coming, everybody.
yep. Thanks.
We'll have the Linux User Social Hour, or the Lush, at your own house. So feel free to get drunk because you don't have to drive anywhere. And we're going to be hanging out on the IRC channel after this. So jump onto that. It's JaxLUG on Freenode. And nice to see everybody. And thank you very much to our presenter as well, again. And thank you everybody for coming out. And have a nice
Yeah.
evening.
See you later.